All right, let's start. Does the microphone works? All right, cool. All right, so today we will talk about how MySQL server can attack you. So my name is Alex, and I am a principal security engineer at AWS, Amazon Web Services. So I have been working as a database engineer for a long time. I started working at MySQL AB, the company behind MySQL, in 2006. And I worked as a consultant and architect, and I worked at Sun Microsystems when Sun acquired MySQL and then Oracle. And then I joined Amazon Web Services, working as a database engineer about 4 years ago. And I switched to security. I started a new team at AWS, which we called Red Team. So we're working on security research on the relational database as a service, doing also open source security research. And this is the result of this research, this finding is the result of our work. So I'm currently leading database security team. We call it Red Team. So this is what we are going to demo today. So imagine that you have a website. And this website has been hacked. The good news is that there were nothing on this website except for the static or database content pages. So now what you will be doing is you will connect to your database server. It's your database server, right? And then you will try to restore the database. And then, actually, the bad actor who hacked the website also controls the MySQL server. Now you establish connection to your own database server. You think that it belongs to you, but now because it's controlled by this hacker, the hacker will actually take control over your workstation. This is what we're going to demo. So how this is even possible? So this is our plan for today. We will actually do this. We'll try to do that. I'll show you the demo. So we found a remote code execution in MySQL client library, MariaDB client library. This is a protocol thing. And actually, that has been found before us. This has been found in 2019 and silently fixed in MySQL. So we basically re-implemented it. We also found a year ago, we found a way to bypass the fix. So 2019, the issue has been there, and then it was fixed, and then in 2023, we found a way to bypass the fix. We submitted it to Oracle MySQL, and it has a CVE. I'll do the number of recorded demos, and then we'll talk about how to protect against this. So to really understand why this is happening, we will need to actually explain the MySQL binary protocol. So here is the MySQL binary protocol oversimplified. We have MySQL client, and that can be your workstation or command line client or something. And then we have a server. So MySQL client connects to the server. Server already gave it the prompt. And then MySQL client is trying to do authentication. And it says, hello, MySQL server. Authentication, please. I have a username and password, actually hash of the password. And then I will be using MySQL client, will be using MySQL native password plugin. So there is a thing called plugins. And the server said, very good. I loaded MySQL native password plugin, and I checked your username and password, access granted. So all good, right? So MySQL send the information about the username, password hash, and the plugin. And then let's say another situation. A MySQL client will establish the connection, and then MySQL client will tell the server, I want to use whatever plugin. Right? And the server said, nah, I don't know what this whatever plugin is. Let's use another plugin. And what will happen is the MySQL client will actually comply and will try to load that with another plugin. Right? What does it load mean here? What does it mean that I will load the plugin? It's actually deal open. So let's take a look at the MySQL source code. So again, the summary here is MySQL server can tell client what plugin to load. And the MySQL client will try to load that plugin. So plugin is a shared library. It's it is the way how you implement authentication. And you can also write your own plugin. It's a pluggable authentication. So what does load mean? So on Linux, we have deal open. On Windows, we have load library. And then that was me looking at that and analyzing the protocol. Because that really means that you can actually execute the code, right? So again, let's look at the code, the source code of this client library. So MySQL server has both client component in open source, right? Have both client component and server component. This code is from the client part. So what is happening here? We have the name of the plugin, and it comes from the server. Then we have a plugin dir. This is a specific directory that the client will load the plugins from. And finally, it will do a deal open. So this code is actually vulnerable. Why is that? So the plugins are located inside the plugin dir. And the plugin dir this directory cannot be changed in the server, on the server side. But what if we'll do a directory traversal? So the directory traversal is easy here. You pass as name can contain, it was able to do that before, could have contained this ... What that really means is that if you can do that, you can load an arbitrary piece of code from anywhere on your client side. Right? So this is an arbitrary code execution via directory traversal. So that was actually found and fixed in 2019. And it started as a HackerOne report against MariaDB server. MariaDB is a fork of MySQL. It started as a fork, and it's actually the separate product right now. So this text explains everything and basically talk about why it's bad and what can happen. And then in June 12th, it was reported, and in August, it was fixed and released. And here's the fix. We can look at this client plugin C code. SQL Common Client Plugin C. It's both in MariaDB and MySQL. And then we can see that this one is actually checking it's sanitizing the input. It's checking for the plugin name, right? Because plugin name is just a name. It should not contain any paths or anything like that, right? So now in November 21st, it was also pushed to MySQL community. MySQL community is a code, right? MySQL community code is managed by Oracle, and they're very strict and they're very secretive, I would say, about the disclosing the actual vulnerabilities. But we can look at the commits. And the commits are usually shows what is being fixed. So here it refers to non-public internal bug, but in the commit text we can see what they're fixing and what the problem is and stuff like that. All right, so that was committed in 2019. So here's what they have done. So this fix is actually different from MariaDB. What it is doing is it's trying to find the separator. And the separator is different on Linux and Windows, so there is a variable for that. And it's trying to find the separator, and if it finds the slash or backslash, then it will say no paths allowed for the shared line, right? So this is has been fixed in 2019, and everything seems good. So here's the quick summary of the directory traversal issue. Again, server can push the code, client can load that code. If we're using older versions, then we are vulnerable. But now let's see how we can implement this. So our goal now is to actually attack this MySQL database administrator who is trying to connect to their own website. So how does it work? So we should have MySQL MariaDB server, any version, right? It doesn't matter. What matters is the client library. And then the database administrator will connect to our server that we now control using command line tools or GUI tools. Does every one of you used any GUI tools to connect to MySQL? Like MySQL Workbench? Raise your hands if you have not used any GUI tools to connect to MySQL. All right. So GUI tools, MySQL Workbench, there are other GUI tools that you can use, or you can use the MySQL command line, and this is the same thing. So what do we need as a red team, a hacker, attacker, right, to actually implement this? We need to control the server. We need to have our victim to use the vulnerable version. And we'll also need the ability to push the code to the MySQL database machine, right? Because MySQL database machine is actually your laptop or maybe a web server, I don't know. So we don't know what is there. How do we push this shared library? Sounds complicated? So let's take a look. So first we'll need to start with how do we push the plugin name with the directory traversal, right? We control the server. There are a couple ways that how we can do that. We can take the existing server and we can write and create a plugin. Or we can create a fake server. So I have decided to actually implement a fake rogue server in Python. It's actually very easy to do. So let's plan our attack. First, we need to write a rogue server with the ability to push the plugin. Second, we need to load an arbitrary file as a shared library. So we need to implement a shared library. And then finally, we need to somehow push that shared library into the database administrator machine. So the Python have the library called MySQL Mimic. And this library is very easy to use, and it implements MySQL protocol. It also supports SSL, everything. So, to implement what we need to do is we need to just install the MySQL mimic and reload a couple of classes. So here I just import the MySQL mimic, and then what I'm doing is I am implementing the code for the number of classes, right? I'm targeting the class that is implementing authentication, obviously. So then I pretty much push whatever string that I provide as a starting when I start this server, right? So it's super easy. I start the server now, and I specify which port I want to listen, and then I specify the string. And the string will be pushed from the server to the client as a plugin name. So let's take a look how it works. Here I'm configuring the ODBC driver, which is used MySQL driver. And the version is very old, 8.0.18. Then I'm trying to establish the connection. And what happens is that it tries to do DL open. At this point, I don't care if it loads it or not. I just want to verify that my server is working. So what we can see here is it attempts to load the shared library from disk. And there's nothing there, but it actually demonstrates that the code is working. Right? So injection worked. So basically, again, I replaced the server. I killed the original MySQL server, and I now start the Python, which will be listening on the same port, and then the only thing that I will be doing is it will be pushing the plugin. So that part is done. The next thing is we need to load an arbitrary name as a shared library. So first, let's start building this, creating this shared library, right? So how do we actually load the exploit code? The good news is we don't need to implement the whole authentication. In Linux, it's easy. Whatever you place into the init section of your shared library will be executed. Right? So we will need to have a shared library, and we'll need to push it to the user's workstation. So this is the example of the code. The only thing I do, I put some execs inside of the init. And then what I'm doing is I'm creating a file on disk, and also I'm trying to open a calculator application on my laptop. So then I will compile it as a shared library with GCC, and that will be my shared SO. Now, another interesting thing here is we can see in the code that it will add the SO extension. On Linux, it's .so. On Windows, it's DLO. It will be nice if we will be able to load any arbitrary file as a shared library. Now let's look at the code. This is probably the oldest piece of code which is still in MySQL server and MariaDB server. This is written in 1984 by Richard O'Keefe, who is a very famous computer scientist actually. And what we can see here is it's actually implementing the string copy. And what happens here is it's a length overflow. So this ref length is defined as 512 bytes. If we will create the plugin name precisely, which will be more than 512 bytes, it will push out our extension. Right? It's not a memory corruption. It's not the real buffer overflow. It's just pushing out the SO extension because it doesn't check the final size. So with that, we can actually create a modified version of our Python server, and we'll be able to calculate the amount of bytes that we will push as a plugin name, and we'll push out the SO part or DLL part, and then we can really load the arbitrary file as a shared library. Right? So again, we have this rogue server in Python, and we run it, and now we connect to that, right? And it will try to load the aaa.so. So now I have created this function, generate injection string. Don't judge me on Python code quality. It is quick and dirty, but basically what I'm doing is, on Linux and on Windows as well, the number of slashes doesn't matter. It's still the same path. So I take my directory traversal string, and then I'm calculating the number of slashes that I need to push. So I start with 512, and then I deduct the size of the plugin dir, and then the length of the file name and traverse and stuff like that. So then I generate precisely the number of slashes I need to add, and generate the injection string, the plugin name string. So then I change the start rogue server and push the injection string that I have calculated using this function. So now I will be able to load an arbitrary name. For example, I can disguise my code as a picture. So I have renamed my shared library as TMP PNG file. And this is really the payload. So now I start my rogue server. I generated an injection string based off the file name. And then I'm waiting for the connections. So now I connect to that MySQL, fake MySQL server, and it looks like it works, right? So what happens is that it's actually cut off the error because of that length overflow. But we can actually verify that it's trying to do this. Right? It's doing open add. So I'm using strace. So it's trying to open the PWN PNG. If I have missed one byte, then it will have tried to open PWN PNG dot, or 2 bytes, dot S, and so on. Right? So with the strace, I can actually debug my function. So now, finally, is how do we push the exploit code to the database administrator machine? So now we have a code. We have the ability to load an arbitrary file. The only thing we need to have is we need to have that code on the DBA machine. We can use some social engineering and disguise our code as a resume. So imagine I send you my resume. What would you do? You will probably load, you will not load it, right? You will save it on your machine somewhere. You don't need to load it. You don't need to open it. If you will open it, it will give you an error. But you don't need to do that. So when I send you a resume, you probably save it somewhere where, especially if you're lazy like I am, you can load it to something like home downloads or home documents, right? Or whatever the windows you have. So I have a number of attempts to try to find them. So now we have everything in place, and I'll do a recorded demo. So here, my colleague Martin sent me a resume. And this is the resume, and if you run file on it, you will notice that it's not PDF. It's actually a linked shared library for the Intel CPU. It's a code. And you can see that what the origin was for that code. So now I have here, this is my machine. Me here is a victim. And I also have this, my hacked database in a virtual machine. And here, me as a hacker have replaced the MySQL server and started it with the parameters. So now, back to the victim, they have the old version of MySQL Workbench, 8.0 whatever, before the fix, and they connect to my hacked database. And also they have the plugin dir configured here. Right? So now, this victim will try to establish the connection. Here it goes. Calculate. Right? So this is the hack. You will also notice that there is an error here. And the error, because of course it's not the real, it's not the valid auth plugin. We could have implemented a valid plugin, a fake plugin, so that this error will not happen. But at this point, we don't care. All right. So here's another demo on Windows. It's pretty much the same demo. I think we have enough time to do that. So on Windows, we just do a message box. And we have this DLL file here. And what will happen, we will use the same Workbench, the old version of Workbench, 8.0.18. What is different on Windows, this plugin doesn't even need to be configured, the plugin dir. Right? It's just there's nothing in the advanced section of this. So now we establish the connection, and we get the pawn thing, right? And we can also see it in the process also. This Amber DLL is being loaded. All right. So what's next? About a year ago, February 2023, we have discovered the new security issue, a bypass to that fixed MySQL issue, right? And we actually submitted that to Oracle MySQL, and we got CVE. And that has been fixed in a GitHub commit. But before we'll go to GitHub commit, let me explain what this is. I hope you can see this black background. Now, let's take a look at this stream comparison function, right? Right here. Right here. What is this? CS. That's a character set. So MySQL supports lots of different character sets. And this character set is actually part of that function. So the character sets supported are Latin 1 or UTF-8 or something else. But now there are multi-byte character sets, right? And UTF-8 is an example of multi-byte character set. But there is different implementations of multi-byte character set. There's UTF-8 and UTF-16. So do you know the difference? And the difference is that how it handles the multiple bytes. In UTF-8, it will be variable. It will be variable length. If it's a ASCII character, it will be 1 byte. If it's a different character, like Chinese, it can be 3 bytes. But UTF-16 is always 2 bytes. So what happens here is it will take the character set into consideration where it compares and searches inside the string. So if it's 1 byte, it will go 1 by 1. If it's 2 bytes, it will skip over. So remember the original code that fixes the fix, right? So it will search for the separator. If we have 2 bytes, then the search will skip over. So if we will be able to push the character set to our program, then this fix is not valid anymore. And this is exactly what it discusses. MySQL calls it invalid or not supported character set. So the funny thing is, it has been supported before the fix. In the client library, it was supported. So now the fix is actually remove support for this multi-byte character set in the client library. Server still supports it, but the client doesn't. Right? So you can use UTF-16, UTF-32, UCS2, and other multi-byte character sets that always use multiple bytes. So this is the demo for the newer Workbench. This is all based off Windows demos. So the newer MySQL Workbench, and we managed somehow to push this unsupported character set name or convince or basically it's not a standard configuration. So the MySQL database administrator may have used this UTF-16 character set in their configuration. Right? And in this case, what will happen is it's still unfixed. So we try to establish the connection and we have a calculator again. Right? Again, this is post-fix issue 1. It's version 8030, which has the original fix. Right? So now let's take a look at the MySQL command line client. Can you see this? I hope so. So this is the MySQL command line client. We have this DLL again here. And let's look at how different versions I actually handle that. So this is MySQL version 8032. That's the postfix of issue number 1. Right? So we try to load it and it says no paths allowed for the shared library. Now let's add the default character set. We do default character set UTF-16. There you go. We got pwned again. Alright, so let's now verify that it has been fixed. Now let's do the version again. This is final fix, 8033. So what we'll verify that the issue number 1 is still fixed, right? No paths allowed. And now we will try to verify that the second issue is fixed. So we provide the default character set again, UTF-16. Right, and then it says UTF-16 character set is not, multibyte, cannot be used. It's not supported in the client. This was the final fix. All right, so this is our attack. We have successfully implemented the attack against MySQL client. This is, I would say, it's unusual attack, right? Usually we think about attacking MySQL server or any database server. Now this is a reverse attack. You control the server. Now you want to move to another system, in this case, database administrator laptop. But it can be anything. It can be application server, it can be web server, and stuff like that. Quick recap, versions. 2019 issue, original, all the versions that are released before 2019 is probably affected. That applies to MySQL client, MariaDB client, Percona server client as well. Percona server is a fork of MySQL server. 2023 issue only applies to MySQL. It doesn't apply to MariaDB because MariaDB pretty much sanitized the whole input. Fixed is released in April 2023. What are the clients affected? So this code is C, C++. Pretty old code. Everything that is built off that code is affected. So GUI tools are based on libmysql or connected C++ or ODBC driver will be affected. Any native implementation of the MySQL protocol is probably not affected. GDBC is not affected. Go implementation, native Go implementation, Python Go implementation is not affected. If we are talking about really old stuff, like Perl DBD driver, anyone remembers Perl? So those are also affected because they are using the libmysql. So you need to upgrade. You need to upgrade to the latest version of MySQL client. Right, so summary and conclusion again. I think I talked about that. The summary here is you need to upgrade. The conclusion is the multi-byte unsafe string comparison is dangerous. If you have a C code and if you have a function written in 1982 or 1984, before all this UTF stuff, multi-byte stuff, then you need to check that it works fine with a multi-byte. And always upgrade. That's it. Thank you very much. All right, any questions? Yes.
So if I'm injecting a DLL, suppose, I wanted to know, is the execution of DLL and how it runs, is it persistent even if I close the SQL workbench? And with what privileges does it run? Is it running with the same privileges I'm launching my SQL server on my client?
Yeah, this is a good question. So, first of all, MySQL server doesn't matter in this case.
Okay.
Whatever matters is a client, right? So on your laptop, you probably run the program with your user. If you're an administrator, I can do anything on that, right? If you have administrative rights. on that. So this is the user that you get. Now, the question about the persistence, right? So for you, I run the code here, right? I run the calculator. That's it. But now, in the real world, if this is a real bad actor, I would invoke something which I can maintain persistence on your system, right? And then I will probably use something like command and control, or if I just need to infiltrate something, just a reverse shell or something similar to that, right? So this is basically it. So you need to maintain the persistence. So if a user closes the laptop, opens the laptop, you'll be able to reconnect to that. So probably command and control systems.
So like the closing of all the processes related to SQL is not handled in the code, right?
It's not SQL, first of all, right? So it's a code, but it depends upon how good this bad actor is. If you have an ability to execute code, if you have been hacked, you will need to re-image. Even re-imaging may not be sufficient if there is a way to get into BIOS or something like that, right? But it's probably less issue in Mac. But pretty much if you have the ability to execute code from the administrator, from a root user on your system, that's it. You have them hacked. It's now this whoever hacked your MySQL server now possess your laptop. That's it. And then this is super dangerous because we have VPNs, we have corporate access and stuff like that. So, any other questions? Yes.
Is there something about the way that MySQL involves plugins that makes it vulnerable compared to other databases?
Yeah, this is MySQL thing. So let me quickly go here. So this is, let me open this picture. Right. So this is how the MySQL implements authentication. It's a plugin-based authentication. So a client can actually tell the server to load the plugin. This is MySQL specific protocol. It's probably not in the other databases as is, right? MySQL has a history of doing things with custom logic in it. You can extend MySQL. You can create your own storage engine. You can create your own authentication plugin. This thing is a little bit different to other features in other databases like user-defined function or code execution, right? So this is a very specific thing in MySQL. All right? Any other questions? All right, thank you very much.